Hello, we will be demonstrating the code for Lab 3. We will be doing it from the GitHub link, mainly because many of the models that we have to run take some time. So I'll just run through the code, explain it, and show screenshots of the respective outputs. So first question, we are building a sequential model using Keras um, to implement linear regression with any dataset. So here we are using the ESP studies dataset, and here we are going to look through the um, CSV file, see the different um, columns in the set, and we're going to create a model to try and predict if the user has ESP in the final. So here we are creating this sequential model with various um, dense layers over here. And we add a dropout layer of 0.1 using atom optimizer of 0.01. And the outputs, or this is the remainder of the code that is mainly used to create the plot. And here is our model loss, comparing the training and test data. And here it is displayed on TensorFlow. Part B, um, we are going to plot and then change the below parameter and review how the results change in each case. So let's put this up here. This is the original model that we created. And here's the learning rate change, the batch size change, um, when we change the optimizer, and here when we change the activation from prelude to sigmoid. Okay, to question 2, we are implementing logistic regression on the heart disease UCI dataset, and then we will again use Keras to create another sequential model. Here is the code. Here we're loading the CSV file that we're going to use, and then we'll create the training sequential model. Once we create the actual model, and then here's more stuff for the plot, and this is what we got for the from using TensorFlow to show the loss. Forgot to mention prior to that we did normalization on the actual data model. And for third question, we are implementing image classification with a CNN model on the natural images data set. Over here we are unloading the necessary libraries, and we use this part over here to access the image file data set that was saved to a local directory. And then here we resize the image, and then we create an empty data array where we will pretty much in the new array that we're creating for the training data, we are going to put the images are going to be converted to grayscale. We um, select the image size at 32, and we will append them into the training data. On the next part of the code over here, um, so we'll actually do some normalization. So once we create the training data, we actually random shuffle it just to make sure when the data is going through the model, it's not all one after another of the same thing when it runs through the model. So anyways, we add those different features and the label to them. And then this is we use the sequential model, and and here is the actual model right here. And the results we got after running the code, and this is our validation accuracy over here. Number 4, we are implementing the text classification with CNN model on the following Ruby reviews datasets. So here's the code loading the different libraries that we will be using as shown in the class. Once we load the train CSV file, we go to the next part. We use label encoder. This part pretty much, I think it allows us to tokenize it. I think that's the word. Tokenize the different data points. Here we create a model. We do CNN, we do dropout layers, we do max pooling over here, flatten the model, dense layer will be the number of classes, soft max activation, 2 epochs, that's our L rate, and over here we have our output. This is from when Alper ran the code, and the percent accuracy was 50.48%. Going on to number 5, we do the same thing with the same data set, only we are going to be using LSTM model instead of CNN. So the code over here, most of the code will be slightly the same. The only major change would be the model. Here is here we create the model, sequential model, and here's where we apply the LSTM, long short-term memory, to it. And our output, once it's run, here are our results. Hopefully you got better accuracy. And anyways, finally, to number 6, we will actually compare the results from question number 4 and 5, and to see which model gave us the best results for our text classification. As stated, we used the LSTM model, and from here the code, we got about 62% accuracy, compared to 50.48 with the CNN model. So in this situation, the long short-term memory model was better at making a more accurate prediction. Here we followed different changes that we made to the model to kind of see what changes were made to the results. When we added more layers, the accuracy went up slightly. When we changed epoch to 2 to 5, same situation, it went up slightly. The accuracy remained unchanged when we used sigmoid function instead of the ReLU. When we used the TANH instead of ReLU in the CNN model, the accuracy increased from 50.48 to 50.91. When we changed the learning rate from 0.01 to 0.02, we actually saw a slight increase in the model accuracy. And I'll just run through these. The models are roughly the same except for the slight um, variance made into the sequential model. That was for changing the layer number. Here we changed epochs to 5. Here we used the sigmoid function instead. TANH. And then here we finally changed the learning rate from 0.01 to 0.02. And that is the demonstration for the code for Lab 3. Thank you.